Your application just went live, users are hitting it, logs are flooding in, CPU is spiking, and suddenly things start slowing down. This is what real production looks like. In this final episode of Docker HomeLab series, we will simulate a mini production environment, Flask application, Postgres Database, Nginx Load Balancer, and live monitoring. Then we'll push traffic, break it, scale it, just like you would do in a real DevOps job. This is the last episode of this Docker HomeLab series. If you missed the earlier ones, go back to episode 1 where we started with Docker versus VMs and follow the whole journey step by step. Hit subscribe right now because by the end of this video, you won't just be running containers, you will be running them like in production. Let me quickly draw today's setup. Users are going to talk to Nginx. From here, it is going to connect to the Flask containers, Flask application. Flask will connect to the Postgres database, cAdvisor on the side. Here's our today's setup. Users are going to hit Nginx. Nginx load balances across multiple Flask containers. Flask connects to the Postgres with persistent storage, and cAdvisor gives us live monitoring what's going on with our containers. This is as close as you can get to production in a home lab. Let's jump into the demo. So I'm going to open my Visual Studio Code. In my Visual Studio Code, I have episode 10, real world simulation, Flask application. In this folder, I have application.py. It's the same exact file which I'm using from previous episodes. Docker file is also same. Then we have requirements.txt, .docker ignore, followed by .env file, docker compose.yaml, nginx.config. So let's look at our docker compose.yaml file now. First, we are going to start with application, where we are going to build, and it depends on database. Then we are trying to pass some environment variables, db host, db user, password, name using our .env file. Then we are going to expose 5000 so Nginx can reach it internally. We are not publishing here, we are just exposing the ports. Restart unless stopped. Followed by, here comes our second service, database service. Image, environment variables, once again db user, password, db name, volumes, db data, restart policy, once again the same. Then comes our Nginx load balancer. So Nginx image, public entry point port 80, volumes, this particular configuration file we are passing it from here. If you can see, I showed in the previous episode exactly the same file, and depends on application. Restart the same unless stopped. And finally, cAdvisor for monitoring. Here I'm using image from Google Container Registry. Map container port 8080. This means you can access cAdvisor's UI and metrics endpoint at localhost 8080. Followed by, we have volumes. So what exactly these volumes are going to do? First one, mounts the host's root file system read only. Second, var run gives access to the Docker socket and process info. Sys folder mounts the Linux sysfs kernel data like CPU, memory, stats. Finally, var lib docker mounts Docker's internal storage to inspect container metadata. These mounts give cAdvisor deep visibility into the host and containers. They are required for full metrics, but note that it's privileged access. Then finally, restart policy, container automatically restarts if it crashes or the host reboots. Now we are going to run our stack with a single command. With a single command, we have our DB, cAdvisor monitoring tool, application, Nginx Load Balancer. Now we are going to do a small mistake. I am going to use Docker compose command here and try to pass scale app is equal to 1. So currently only one application is running. We are going to do a load test here using Apache benchmark tool. We are going to run so many requests, 50 concurrent requests at a time at our local host. Press enter. Now let's jump back to our cAdvisor. It is running fine. I'm going to jump to my Docker containers. In the Docker containers, I can see real world DB1, application 1. I'm going to open this particular container. If you see, we can see some spikes here. So it is coming down, going up, coming down. We are sending so many requests at a time with only one application container. Our servers can't keep up. Requests are slower, CPU spikes as you can see clearly, and logs shows connection delays. This is what happens when you underestimate traffic. Now we are going to scale our containers. Application would be 2 containers instead of 1. Press enter. Followed by we are going to start load testing once again. Press enter. Jump back to our browser. I'm going to go back to my Docker containers. Refresh the page. I can see application 2 once again. So here if you scroll down, Nginx will try to distribute the traffic. We should not see many spikes here. So I cannot see anything here. Let me open another tab and jump back to application 1. So application 1 container. So if you see, it has some spikes, whereas application container 2 doesn't have much. And there it is. Smooth again. Nginx distributes the traffic. Each container takes half the load and our response time drops immediately. That's real world horizontal scaling in action. We can scale more if we are interested. For example, I'm going to run 10 containers here. Press enter so that the traffic gets distributed. Right now I'm seeing some spikes on container 1. So this should go down as soon as we have more containers. So let me refresh this. So application 6. It will take some time, let's say a few seconds to reflect here. This is how we run production like simulation locally on our computer. I'm going to scale down. Once again, I'm going to move back to application 1. That's how you scale up and scale down just by, updating the values on the command line. Let's do a quick recap of this entire episode. We built a production style Docker Compose stack. We overloaded with traffic to simulate failure. We scaled out the application layer to fix it. And we monitored the results in real time. This is the DevOps way of thinking. Don't just run containers, run them like in production. That's it. End of the Docker HomeLab series. From episode 1 to 10, we covered everything from Docker basics to debugging volumes, networking, security, CI/CD, and now a full production simulation. If you followed along, you now understand Docker like a real engineer. Next season, we'll go beyond Docker into Kubernetes and cloud deployments. So hit like, subscribe and share this playlist with someone who want to master Docker. Thank you for sticking with me for the whole Docker HomeLab series. I'll see you in the next video.